Okay, so up to this point we've created the habitat model and figured out the highest probability of sighting areas. And we've done a little bit of evaluation against our, a little ground truthing basically. But now we want to go back to the original question of which tour company has the best chance, like with, near it, within 10 kilometers of each tour company, which one has the highest or the greatest length of road passing through these high probability areas, to figure out which one is, the best suited for carrying out these tours. So let's clear our selection, get rid of the skunk sightings. This is our high probability area, and now we've got roads. So what we want to do is figure out what the total length of road is that intersects the high probability area that's within 10 kilometers of each of the tour companies. So here are our tour starts. Let's do a quick, for fun and refresher. Let's symbolize by category, by company, add all the values. Let's increase the size here. And just refresh this to give it a little bit brighter colors. Let's try it again and see if we can get that to be a little bit even better. It's not so hot, but okay, let's do that. And then, well, you can see them. Okay, so here are 4 different tour starts. We're going to run a 10-kilometer buffer around each tour company start. We're going to intersect the roads with this high probability layer, and then we're going to calculate the total length of road that falls within 10 kilometers. And it's not as bad as it sounds. I know the instructions, it's really hard to write these things out, but that's pretty logical, right? So let's start by running an intersect. We're going to intersect the high probability area and the roads. So remember, intersect is kind of like a clip, but it is going to maintain the attributes of the 2 input layers. A clip ignores the attributes of your clipping layer, but we're just going to run an intersect in this point. Again, it should be defaulting to my dry run. We'll call this high prob roads, and leave all the rest of those things. It's pretty quick. Let's turn off all of our other roads, and we've just got our high probability roads. We can even turn this guy off. So it looks kind of, boring, but these are the little sections of roads that run through the high probability area. All right, now we're going to buffer our tour company locations. So our input features are Skunk tour starts. Let's call it Tour Co 10 kilometer. We don't really need to dissolve this at all because they shouldn't overlap in any way. Okay, so that seems reasonable. We can double check here if I can get ARC to cooperate with me. All right, so I'm going to measure from the center out, and it should be roughly 10 kilometers, and it is. Okay, so I feel good about the buffers. I've got the total section of road. The question is, how are we going to figure out the total length? And this is just the brilliance of GIS. We can do it in such an easy way. One thing to check, we want to make sure that our tour company buffers have the company name, and that is carried through here. So that's good news. That's going to be important for our next step here. So remember how I was saying that with a clip, your clip feature acts as a cookie cutter and ignores the attributes of that. But the buffer, it's really important that we maintain the company name associated with the road lengths so that we can sum up the total lengths per tour company. And so we can't use a clip in this instance, and we're going to end up using an intersect again. Now the instructions walk you through doing the clip just so you can see the difference. Clip is still a really useful thing, and I do clip 99 out of 100 times, but every once in a while you do need to preserve the names. It's nice sometimes to keep your attribute tables nice and clean. And so if you're really just trying to cut something down to get rid of stuff, to keep your data simple or processing time simple, clip is the best way to go. But every once in a while you do need to preserve those attributes of your clipping feature, and so intersect is the way to do it. Okay, so we're going to intersect our tour company 10-kilometer buffers with the roads, and we want our high probability roads. And let's, I don't know what to call this. Let's call it tour co roads. We don't have anything like that yet. That's what it is. We want to join all of our attributes and run it like that. Now, it doesn't look like anything's changed, but again, if we turn off all of our inputs, you'll see that we do have just the roads within 10 kilometers of each company. Now, the key is we have to check that we've maintained the tour company per little road segment. So we've got 59 little tour company, 59 little road segments. But what we want to make, what we want to make sure that we've got here is a company name for each record, and all the road stuff is in there as well. So let's just say we want to test this by selecting a couple of these. We've got one little segment out of 59. It's attributing it to we want the skunk. So is this we want the skunk? We want the skunk is the dark blue one. So that's good news. Another thing that's a little funky is that we selected two of these and it was just one record in the attribute table. If that was troubling for you, we can do an explode multi-part and get all of these little segments as their own record. That shouldn't really matter, but let's walk through it just for the exercise of it. I'm going to stop this and pick up there in a new part.